So a couple things that we've already talked about in chapter 1 is we revisited what the 4 quadrants were, right? So quadrant 1, do you guys remember, is the top right quadrant? So this is quadrant 1. This would be quadrant 2. Lower left is quadrant 3. And then lower right is quadrant 4. Okay, so what I want us to do right now is we're going to talk about what all the degrees would be. So we're going to put all the degrees in these dashed marks. Okay, so do you guys agree that standard position we talked about, you always start on the positive x-axis? So if I start right here and I haven't moved at all, that would be 0 degrees. But if I go all the way around, how many degrees would that be? 360. Okay. Half of the circle would be how many degrees? 180. Okay. Half of half would be 90. Then, if this is 90, what would half of 90 be? 45. So the angle in the middle is 45 degrees. Okay. So what I'm going to do is we're going to start by going every 45 degree angle. So all the angles that are the same like distance away from the x-axis. So this middle angle, guys, is like the 45 degree angle in this quadrant. This middle angle is the 45 degree angle in this quadrant. Same thing here. All of these have special properties. So 45 degrees after 45 degrees, you guys agree is 90, right? What would 45 degrees after 90 be? 135. Okay, make sure you guys include the degree symbol whenever we're talking about degrees. So another 45 gives us 180. What would another 45 give us? 225. And then what would this be? I think I heard it. Good, 270. And then another 45 degrees gives us? Yes. Okay, so what I'm going to do is I want you guys to, and hopefully your table friends have highlighters. We're going to highlight each of the special angles. All of the middle angles, so all the ones that are 45, we're going to highlight with one color. Okay. Now, in degrees, this may not make as much sense, but this will make more sense once we do everything in radians here shortly. Now, do you guys see that in each quadrant, there's also 2 other angles? Okay. All of these also share special properties. So, can everybody look at the screen? We have this angle right here and this angle on this side. Do you guys agree that between these 3 angles, this angle is closest to the x-axis? And same thing over here. This angle is closest to the x-axis. This angle is closest to the x-axis in this quadrant. This angle is closest to the x-axis in this quadrant. So all 4 of these angles also share special properties. Okay, so I'm going to highlight those 4 with one color. And then the angles that we haven't highlighted yet, do you guys agree that these 4 angles are closest to which axis? The y-axis. Okay, so I'm going to highlight those in a different color. Okay, so all of these in degrees, all the blue ones I highlighted, the ones that are closest to the x-axis, those are my 30-degree angles. So this angle right here is 30 degrees in the positive direction off of the x-axis. So this is 30 degrees. This angle is 30 degrees backwards of 180. 150. This is 30 degrees past 180. 210. This angle is 30 degrees less than 360. So it'd be 330. Okay, is everybody cool with that? Talk to me, guys. Is everyone cool with where those numbers came from? Okay. Now, all of the green angles, the ones that are closest to the y-axis, these are my 60-degree angles. So this angle right here is going to be 60 degrees. Now, what's the distance between these two angles? 30. So I'm going to go 30 degrees forward. So 90 plus 30 gives me 120. These are 30 degrees apart. So going backwards, 270 minus 30 gives me 240. If I add another 30 degrees, this gives me 300. Okay, so these are all of my degrees angles of my unit circle. Okay, the other blanks are the radian values. So I want to show you guys where those come from right now. Okay, is everyone cool with this? Now this is going to be the unit circle that you guys are going to use as like your little cheat sheet, assuming that you guys are going to make flashcards like I asked you guys to. But please don't lose this because you guys are going to put a lot of work into this over the next week. So please don't misplace this. Okay, so let's go back to our notes. So, whoa. Leave some space because we're going to write something before we put it in the box. All right, the measure of an angle can also be measured using radians, which we use in calculus. To define a radian, we can use a circle and a central angle. So this will probably be super confusing at first, but I'll do my best to explain where this comes from. Okay, once you guys copy that down, go ahead and tape in the box if you guys haven't yet. All right, so 1 radian. What does radian sound like? What word does it sound like? Radius. Okay, so maybe they have something in relation with each other. 1 radian is a measure of a central angle, theta, that intercepts, so crosses, an arc, which we're going to call capital S, equal in length to a radius r of the circle. Algebraically, this means that theta is equal to S divided by r, where theta is measured in radians. Okay, so this is the idea that we're going to use to prove what I'm about to prove to you guys. And some of you guys have seen this already. You're just going to pretend like it's cool because it is cool. This is where it comes from. So if you guys just want to fake it and be like, wow, afterwards, because it actually is kind of cool where this comes from. And if you guys already forgot from last year, that's okay. You guys can be wowed again. So what the heck does this mean? What I want you guys to do is I want you guys to draw a picture that looks like this. We have our axis. And then we just have some circle. I have my iPad so I can cheat and draw a nice circle. You guys just do the best you can. So do you guys agree that the radius is the distance from the center to any point on the circle, right? So just to keep things simple, I'm just going to draw my radius that looks like that. Okay, so this distance is r. Then do you guys agree that this angle, whatever it is just theta? Does that make sense? What this says is a radian, whatever this distance is, kind of looks like a slice of pizza. Whatever this distance is like the same distance as the crust of this little pizza slice. So whatever r is right here, see how it's like curved, but this is a straight line? If I were to straighten out the pizza crust, it would be the same length as this r. So this little arc is whatever s is, and it's the same thing as little r. That's what this is trying to tell you. Okay? And then conveniently, whatever this measure is also theta. Okay, so how does this help us? Well, what if I wanted to take this little distance and wrap it around the entire circle? Okay, I'm curious, how many times would I be able to do that all the way around the circle? So I'm going to redraw my picture. I'm just going to draw a circle. And if you guys have different colors, this would be really cool to use right now. So I don't know what this distance is, but I'm going to guess that this distance is about like yay far. So this would be 1 radius. And then if I picked it up, imagine it like a little string, guys. If I picked it up and then put it back down and stretched it out right there, this would be 2. And if I did it again, it'd be 3. And again, 4. And again, 5. 6. And then just a little bit more. So some of you guys might remember seeing this last year right now. Or in Math 2. If you guys have me for Math 2, I showed you guys this too. So how does this help us? How many lengths does this take? 6 plus a little bit more, right? So to break this down, what that actually does to help us is how much is half a circle? 1, 2, 3, and then do you guys agree a little bit more? What special number do you guys learn in math that is 3 plus a little bit more? Pi. Okay? Which means that if this is pi, 1 pi, then the whole circle would be 2 pi. Okay? So this is where that comes from. So this distance right here is about 0.28. So it's going to be 6.28 radians all the way around the circle. So since 2 pi is approximately 6.28 radians, that means there are just over 6 radius lengths in a full circle. Okay, so the takeaway from this is we could say this means 2 pi is the same thing as how many degrees? 360. And that means that just 1 pi is the same thing as 180 degrees. Okay, so let's go back to our unit circle now, so we can fill out everything using radians. So radians don't have a special symbol afterwards, so it's just the number. Okay, a way that you can automatically tell something is radians or not is if there's a pi in the number. So again, right here, if I don't move at all, that's going to be 0. But if I go all the way around, we said that was how many radians? 2 pi. Is everybody cool with that? What was half the circle again? 1 pi, right? Now the rest of these are fractions. Okay, so this is pi, and that's 180 degrees. This is 90 degrees, right? That's half of this. So to get this radian measure, I just take this and cut it in half. So that's going to be pi over 2. So this is 1 pi over 2. If I go that same distance again, another 90 degrees, another pi over 2. Do you guys agree that would be 2 pi over 2? What happens to the 2's? They just cancel, right? So this is 2 pi over 2. And if I go again, that's how many pi over 2's? 3 pi over 2. So this distance right here is 3 pi over 2. And if I went again, another pi over 2, that'd be 4 pi over 2. But what's 4 divided by 2? 2. So that's where that comes from. Okay? All right. 45 degrees is half of 90. So this value is going to be half of pi over 2. So what's half of a half? 1/4. So this value right here is pi over 4. Okay, and this is really where it comes from, guys. Pi over 4, so this is 1 pi over 4, 2 pi over 4, but we already have it. I go again, this would be 3 pi over 4. If I go again, that'd be 4 pi over 4, but we already have that. Which means that this value is 5 pi over 4. If I go another pi over 4, that'd be 6 pi over 4, but we already have it. 6 plus another pi over 4 would give me 7 pi over 4. Okay. Now, the 30s and 60s are a little confusing because we have to think about fractions and fractions simplifying. Okay? So, question to you guys is, what ratio of 90 degrees is 30 degrees? 1/3. So what is 1/3 of 1/2? What's 1/3 times 1/2? 1/6. So this is pi over 6. Did you already fill it out? Nice. So this is pi over 6. Stay with me, guys. If I go another 30 degrees, you guys agree I'd be right here. So that'd be another pi over 6. What's 2 pi over 6? What's 2 divided by 6 the same as? 1/3. So this would be pi over 3. If I go another 30 degrees, that'd be 3 pi over 6, but we already have that. If I go another 30 degrees, that's 4 pi over 6. What's 4/6 the same as? 2/3. So this is 2 pi over 3. So this was 4. If I go another pi over 6, that'd be 5 pi over 6. Another 30 degrees, we already have that, so this is 6. Another one would give me 7. 7 plus 1 gives me 8. What's 8/6 the same as? 4/3. So 4 pi over 3. So this is 8. Another 30 degrees would give me 9, but we already have it. Another one would give me 10. 10 over 6. What's 10/6 the same as? What goes into 10 that also goes into 6, guys? 2, so it'd be 5 pi over 3. And then this is the 10th 30 degree angle. If I go another 30 degrees, that give me 11 pi over 6. Okay, so you guys don't have to like derive it that way. I just need you guys to know where all these are. Okay, you guys aren't getting tested on this today, but whenever you guys do have your first chapter 2 quiz, this is part of it. You guys will get a blank one of these, and you guys will be timed, and you have to fill out all the angles and also what all of these are. This is what you guys will learn in the next section, okay? And just trust me, by having these memorized, it'll help you guys out a lot in this class and also in whatever class you guys take after this, okay? And it sounds difficult to memorize all this, but you guys, we highlighted these numbers, right? There's a reason why we highlight these, and you guys will see why in the next section. Okay, so let's do another problem now. So keep that out. I'm going to delete this, because we already did it. All right, example 2. So question, is this angle on our unit circle? It is. Which quadrant is this in? Quadrant 1. So the way that you guys can think about this is, you guys obviously probably don't have this memorized yet, and that's okay. What's this the same as in degrees? 60 degrees. Okay, so we can think about that pi over 3 is the same thing as 60 degrees. So to draw this angle, remember, how many degrees is each quadrant worth? 90. So I need to just go a little bit more than halfway. So maybe something like that. That's it. I understand you guys have it in front of you, but it's still important that you guys understand what it looks like. Okay, B. Negative angles are which direction? Clockwise. Okay, so I don't have negative 3 pi over 2 on my unit circle. But what I can think about is, isn't this the same thing as pi over 2 backwards 3 times? Does that make sense? So pi over 2 is the same thing as how many degrees? 90, right? So that would be negative 90, how many times? 3 times. So negative 3 pi over 2 is going to land right there. So I'll just write that off to the side. Negative 3 pi over 2 is the same thing as negative 3 times 90 degrees, which is negative 270 degrees. There's examples in these notes that shows you guys how to convert back and forth. So you guys will see that again. I know we did that in Math 3, but we're going to do it again. Okay, does this make sense, guys? I want to make sure everyone's comfortable. Can you guys give me a nod, thumbs up, something, smile, scream, something? Please don't scream. All right, C. That'd be kind of funny, though. Here's a fun one. Okay, is 5 pi on my unit circle? Nope. What's the largest angle on my unit circle? 2 pi. So I have to think about, okay, well, this is obviously bigger than 2 pi, right? So how many rotations do I need to do? At least 2? Because 2 rotations would be what? 4 pi? What did you say? 4 pi? So do you guys agree I could break this up as 5 pi is the same thing as 2 pi plus 2 pi plus pi? So I'm going to, since it's positive, I'm going to go this way. This would be 2 pi. And then we're going to go again. So that would be 4 pi. Now, pi is how much of the circle? Half. So I'm just going to go around one more half rotation, so something like this. Okay, questions on that? Okay, let's do one more, because we love fractions, right, guys? Love them. D. Okay, is this angle on my unit circle? It's not. Okay, so negative, I know I need to go backwards, right? So we need to think about In the negative direction, is this bigger than or smaller than negative 2 pi? Bigger, right? It's more negative than that. How much more negative is it? Well, do you guys agree that 2 pi is the same thing as, if I want to get a common denominator, do you guys agree 2 pi is the same thing as 2 pi over 1? What would I multiply top and bottom by so I have a common denominator? 4. So if I multiply this by 4, do you guys agree I'd get 8 pi? Okay. So if negative 2 pi is the same thing as negative 8 pi over 4, do you guys agree if I subtract another pi over 4, that'll give me negative 9 pi over 4? Does that make sense? So in other words, this is one rotation going backwards and then another pi over 4. So I'm going to set it up like this. So it's going to be something like this. Like that. Pi over 4 is the same thing as how many degrees? 45. So I'm going to go an extra, like half of a quadrant more, because that would be pi over 4. So something like this. And I want to say, to be honest, your homework, I think, for this section is multiple choice. But do you guys think your test will be multiple choice, or your quiz will be multiple choice? No. So please don't just guess until it's right. Just please make sure you guys are drawing these. And if you really don't know where these come from, instead of just maxing out your answer checks, please ask for help. Talk to your classmates, talk to me. That way I can help you guys, okay? All right, questions? All right. So, next idea is what is called a coterminal angle. So coterminal angles, this was a definition on Friday we talked about. So we're going to revisit that here in a second. But this is how you find a coterminal angle. So we have two different types of measures. We have degrees and radians. So if our angle they give us is already in degrees, then a coterminal angle with that angle will be theta plus or minus 360 degrees times n, where n is just an integer. What type of numbers are integers? Whole numbers. Can they be negative? Yes, integers can be negative, okay? So just no fractional numbers. So you won't say theta plus 1 or 360 times a half. No, it would be 1, 2, 3, 4, negative 1, negative 2, negative 3. We can plug in any number we want. If theta is in radians, then it would be theta plus or minus. What's 360 degrees in radians? 2 pi, so it would be 2 pi times n, where n is still an integer. Okay. So when you guys take your quiz, I'm gonna be honest, guys, I'm kind of living like 1 week at a time right now. I don't know for sure which day your quiz will be, but I'll let you guys know by Wednesday when you guys take your tests, when your next test or quiz will be. Your test is already scheduled, but your quizzes, I am not sure what day yet, but I'll let you guys know by Wednesday. When you guys take your first quiz on this stuff, this is guaranteed to be a question on there. So if you guys want to put a star next to this problem, but I really need you guys to know how to do this one. So sketch each angle, theta, in standard position. Find one positive and one negative coterminal angle. Okay. So for part A, I'll give you guys that theta is equal to 30 degrees. So the first thing you're going to do is you're going to draw this angle on a coordinate plane. Now, when you guys do these, don't stress about like, oh, it has to be perfect 30 degrees. What I don't want you guys to do is something like this. Is that 30 degrees? No, that's closer to like what? 90, but maybe like 80. Looks like 80-ish, 78-ish, something like pretty close to 90. Okay, so 30 degrees, maybe something like this. Do you guys agree? So this would be theta. Now, I'll say this over and over again. A coterminal angle. What does the word terminal means? When something ends, stops. What does co mean? Like, think of a word like cooperation. That means you guys work together. So coterminal means angles that together end in the same place. So that's why the definition says that if I take an angle and add 360 to it, do you guys agree if I'm right here and I go 360 all the way around that I'll land in the same place? That's what you're doing. You're just taking the angle and adding 360 or subtracting 360, and the angle will land in the same place. So to show your work, you're just going to say positive, and we're in degrees, right? Because it says 30 degrees. All I'm going to do is take my angle and add 360. And I just figured out what that is. So 30 degrees plus 360, what is that in degrees? What? 390. And that's all you do. Okay? So, to draw this, I'm going to do it in blue since I wrote in blue. That means I'm going to draw the same angle. So I'm just going to go all the way around and then that little distance right there. So it looks something like this. Okay, questions? So what am I going to do to find the other one? Subtract. So take the same angle I gave you and subtract. So theta minus 360 is the same thing as 30 degrees minus 360, which is, yes, negative 330 degrees. So starting at this position, going all the way around and ending in the same place. So do you guys see how the red arrow, the blue arrow, and the black arrow all meet at the same place? Okay. Okay, do we have questions? Does this make sense? All right, so that was in degrees. So what do you guys think comes next? Radians. Is everybody good? Can I scroll down? Okay. And this is where we'll have to stop after this. Okay, question. Is this angle on our unit circle? It's not. Is it bigger or smaller? Bigger. Okay, so let's think about this. Pi over 2 is the same thing as how many degrees? 90. So that means I'm going to go 90 degrees how many times? 5. So watch what I do. 1, 2, 3, 4, 5. So it's going to go all the way around and then another pi over 2. Now, if you're doing these on your worksheet, homework, test, quiz, whatever, if you guys want to use different colors, because you guys will see in this one, sometimes the little rotations, they kind of blend together and it looks kind of confusing. So to find a positive one, what does our note say to do to find a positive one? Add 2 pi. But the question right here, guys, is, hopefully this makes sense. I could add 2 pi to this, right? But won't that make me go around twice and then a little bit more? Okay, so you could add 2 pi to this, but do you guys agree that's going to make it look a little bit confusing? What else could I do to get another positive one? I could subtract here, because if I subtract, that'll still give me a positive one. What is this minus 2 pi? Pi over 2, good. So that's the same thing as 5 pi over 2 minus 4 pi over 2, which is just pi over 2. So in other words, if your angle is really big, you don't have to add. You could subtract and still get a positive answer. As long as your final answer is positive. If this was a negative, then we don't want to subtract. Does that make sense, guys? I'm just trying to make it easier when you guys draw. If you guys draw a 9 pi over 2, that's going to look a little crazy. Okay, so pi over 2. So pi over 2, you guys agree, is just this. Now, to get a negative one, what does our note say to do? Subtract, right? Now, if I take my theta, hopefully this makes sense. I know there's a few minutes left. If I take my theta and subtract pi over 2, won't I get that? But don't we already know that these are coterminal? So do you guys agree I can just take this value and subtract again? Because then I'll get a negative one. So instead, I'm going to do pi over 2 minus the 4 pi over 2. Are you guys with me? 4 pi over 2 is the same thing as 2 pi, just a common denominator. So this is 1 pi over 2 minus 4. What's 1 minus 4? What? Negative 3. So this should be negative 3 pi over 2. So negative 3 pi over 2 would be that. And I'm proud of myself because I was just looking at my notes from last year. This picture looks much nicer than the picture I drew last year. It looks like a mess last year. My poor students. Okay, we're going to pause here.